In this video, we are going to look at more on functions. Here, we're starting with the algebra of functions. So we can add, subtract, multiply, and divide functions just as you think we typically would. We also will be looking at their domains. So the domain, if you add, subtract, or multiply them, is the intersection of the two main domains, or where they overlap. Let me give you a picture of what that might look like. So if on function A, let's do it in green. It goes from a -6 to a 1, like this. And then function G, let's do that in red. Say it goes from a -2 to 5 here. And it looks like this. Only where they overlap will be where the domain exists if we're adding them together. So it looks like this green and red function only overlap from like a -2 to a +2. So that would be the domain for these. And that may come into play as we look at some of the functions we have down here. Let's look at example 1, and we'll add, subtract, multiply, and divide our functions. What this rule tells us is that if I am given the command to find f plus g of x, we just add the two functions. So let's do that here. Let's change our color. And if I want to add f plus g of x, that just tells me to add the f of x function to the g of x function. That's it, we're done. Kind of what you would probably think how we do it also. But now we need to look at our domain. And I wrote this function incorrectly. That should say the square root of x. The domain, as we looked at in our previous videos, is all values of x should be fine unless they are restricted by the function in some way. So if we look at our first part of our function here, we have a denominator. And we know that denominators can't equal 0. So if I move that 2 over, I get x can't equal 2. And here we know that I can't have a negative underneath my square root. So I say this x has got to be greater than or equal to 0. So if we combine those two qualities together, x has got to be greater than or equal to 0, if this is 0, but it also cannot equal 2. So it can't equal 2, then this domain will exist from 0 to 2 and 2 to infinity. So the domain of this function is 0 to 2, non-inclusive, and then 2 to infinity. Now, if we look up here, for adding, subtracting, and multiplying, that's how it's going to be on the domains. It's their overlap. So that will be the same domain when we subtract them and multiply them. F minus g, if we were given this command of x, would just be my f function, 1 over x minus 2, minus my square root of x, my g function. And its domain would be the same as the domain we got for our first problem here. So it'd be from 0 to 2, and then to infinity. If we look at f times g, similarly, of x, we'll be taking my first function, 1 over x minus 2, and we'll be multiplying it by the square root of x. We can clean that up a little bit as we multiply the numerators and get the square root of x over x minus 2. Its domain is going to be the same as the above two domains. 0 to 2 and 2 to infinity. Finally, if we look at f divided by g, we have the added restriction here that the denominator value cannot equal 0. So that may come to play here. So in problem 1, it wanted us to find the division of the two functions. with the f of x function being in the numerator and the g of x function being in the denominator. So this will change our domain a little bit. We'll still have the fact that x minus 2 can't equal 0. So x will not be able to equal 2, which is the same thing we had above. But here, my square root of x cannot equal 0 either. Before we said that if you have the square root of x, you can have a 0 in there, and it would just equal 0, the square root of 0. But now that x is in the denominator, we'll have that x has got to only be greater than 0. So that's going to change our domain. We can also clean this complex fraction up. My fraction in the numerator is 1 over x minus 2. Now, when you're dividing fractions, you flip the lower fraction and multiply. So I'm going to flip this and multiply it. That's our rule. So this will give us the function of, let's see, it would be 1 over the square root of x times x minus 2. And you could multiply that out, but that would be the function f divided by g. Now our domain will be similar to the ones we had in the past. The only difference is that it will not equal 0. So it'll be from 0 to 2, not inclusive, and then 2 to infinity. Let's try these next problems. Here, they want us to put values into these functions that we have. So if we're doing f plus g of x, and we want to substitute a 4 in, we already found what the f plus g function looks like. I'm going to move this up. Here's our f plus g function right here. So we're going to substitute in a 4 for that function. 1 over 4 minus 2 plus the square root of 4. So that will give us 1 over 2 plus 2, or 2.5. If we look at this one, it wants us to subtract them. So the subtraction of these functions was this one right here. Now we'll plug 2 in for that. So we'll have 1 over 2 minus 2 plus, no, minus the square root of 2. Well, you can see the problem here. We're getting a 0 in the denominator. But we also know that it shouldn't work because part of our domain said that our function never equals 2. We look up here, we crossed it out. So this answer is does not exist. The third one it wants us to find is f times g of 3. Here's my f times g function. I'm sorry, negative 3. But that's not in our domain either because the lowest value in our domain is 0. If we tried to do this, we'd have the square root of negative 3 over negative 3 minus 2. This would be our f of negative 3. Or I'm sorry, our f divided by g of negative 3. But we can't have that because you can't have a negative under the square root. So this is a non-real solution. And finally, it wants us to find f divided by g of 0. And here's our f divided by g function. This one was supposed to be f times of g. But f divided by g would be 1 over the square root of 0 times 0 minus 2. We already identified in our domain that it cannot equal 0. So this one does not exist. All right, in our next video, we will be looking at more from this section. Thanks for watching.